Today we're going to look at object-oriented programming in Python. And I'd say most Python coding is not done in object. It doesn't really utilize object-oriented programming. Python's kind of a neat language. You can write you standard do in a standard programming. In most applications of Python, you may be moving data from one place to another, data manipulation, moving some things around, and in those cases, you're not going to really benefit much from object-oriented programming. However, if you were to make a more complicated program, you may get into object-oriented program. Let's say you're going to make a game or a web app, or some fairly sophisticated inventory control system. You might want to benefit you might benefit from object-oriented programming. And today we're going to start really small and define a very small class, and then we're going to work up to a larger class that where you'd be able to see its benefits in a larger Python programming project that you might be into. So at first, let's just do something really simple. We're going to start way simpler than the book even starts with. We're going to do a bare minimum definition of a class. And this class is going to be virtually nothing. It's going to be, for the most part, useless, but it's going to really tell you the kind of the smallest level of definition of a class that we can have, and then we're going to get into something a little more complex, and hopefully you'd be able to see with the next example how you might even be able to enhance that and be able to use that for something very complex, very cool, and very interesting. But first, we're just going to keep it really simple. We're going to go class. We're going to call it my class, and we're just going to give it number equals 57. And let's print this class. I mean, this is really simplistic. So if we were to print my class, let's see what we get. Okay, we're gonna have to save it. That's fine. Some good number to save. Oh, we're gonna save it at 37. Test 37. Okay. So this kind of goes in the class, my class, and describes it. But if we wanted to get at the actual 57, we can do something like this. Let's go over and go print my class. As I said earlier, this is incredibly simple class, and once we get into it, we're going to be able to change the class a little bit to do more things with it. So we're going to go my class dot number. Let's run that. Okay, and it's 57. And the thing about class is you could define an object of a class, and so we're going to say A equals my class, and what that's going to do it's going to create an object that is this thing up here. And like I said, this is really simplistic. It just basically shows a number 57. But once we get into more complex things, object-oriented programming is wonderful. You could do some very, very impressive things with it. And we're going to see that in a bit. But for now, we're just going to get the real basic concepts. So you define this class. And with this class, you can assign an object, in which is I kind of use those words, class and object, almost synonymously. But a class in Python, you define all the attributes of it, and we could get into do a little more than attributes. We could add methods and stuff as you see later on. But for right now, there's no constructors, so we can't really define anything, and it has just one attribute essentially that doesn't change. 57, number 57. But what I'm doing here with the A equals my class is I'm saying I want A to be an object called my class. And this one's really simple, but once we get going, we're going to make some complex objects that you can do some really, really cool things with. So let's go here. And the neat thing about whenever you get a object of that class, everything in the class is now part of that object. And so basically this class can always have 57 here, and which isn't useful, but in a little bit we see why it is. And a little error here. Oh, there we go. Let's rerun this. Okay, so 57, because that's the really only attribute to it, 57. The important thing about the simple one to understand is that we can assign A to this class, and we can make B, C, so and so. We can have a loop that assigns tons of these classes. And of course, if all it does is have one attribute that there's no mechanism to change, it's not very useful. It's more of a demonstration. But what we're going to do next is we're going to get more complex. And to show you one of the neat things we can do, I'm going to import from the random module, and this is just one of the actual a couple of the methods I want to make for this cool class that we're going to come up with. We'll use random to generate a random int to make our class really really interesting. And for this new class, we're going to want to lay down the basics of kind of a card game, such as the Pokemon card game, or the Magic card game, or any other variety of card games out there. You have Hearthstone by Blizzard out on the internet. There's a lot of these kind of card battle games, and we're gonna make an object that you can use in making one of those such games, and we're going to use random in that. But first, what I'm going to do up here is I'm going to use some comments, and we're going to comment out these prints, because once we get going, we don't want to have to deal with a whole bunch of prints here. Okay, so I'm importing random because we're going to use it in our later in our Python code and actually embed it in our class, which is going to be really, really cool. And if you're not familiar with any of these games and stuff, and I'm using the random just as a kind of like a die roll would be kind of to roll the dice. So I guess we introduced a little more than physical cards would have. We added a little more randomness, more like one of these games. But let's go into this. Let's say we're making our card video game, and we'd make a class because the basic part of it would be card. So we're going to call our class card. So each of these cards that someone can draw it or receive in the game, we're just call it a card. It's going to define what whatever that is, and in the case of something like Digimon or Pokemon or any of those games, you have these little creatures that kind of battle and do their thing. The first part of it is we're gonna make our constructor, which is going to be how it is actually called, and how when you make one of these objects, kind of like we did up here with the A equals my class. And this thing is going to take in it's going to let us take in our parameters in double underscore init. This stand for initialization, and it's basically going to let us take in the parameters that we need to be able to define our card. And once again, this is reserved word double underscore init double underscore, and it's used in object-oriented Python for the initialization parameters pulled in a constructor. So the first thing we're going to do is self, and we just use that to and pretty standard out there, and we're use it later in the definition of the class to literally self-identify as any object made from this class. We're going to give it a name, and we're going to say attack underscore power for your cards, whether the cards end up being little monsters or battle tanks, people running around shooting each other with squirt guns, whatever. In a more complex program, you're gonna be able to define what your game is. You'd have you could use it for a variety of things, but what we're gonna explore here today is just the basic class that you can use to really define your game. And most of these games on the market out there have this, and then a lot of it in the business, in the not as interesting and flashy as these games in the boring business world. Some of the more complex things that you may have records, and might be you benefit from object-oriented programming. Too, you might have something like member, and all the attributes are all the members of someone that may have joined your business, and you could list out all their attributes and keep each member as an object. But we're just gonna stick for now with our card game, or virtual card game. Okay, so the self really is only going to represent this. the actual object. So you have name, attack power, defense, or really these three are your only parameters. And so we have name. And right now, what we're doing is we're going over the attributes of this class or object that we defined from this class. So we have a name, and we're going to have, let's copy that down there to get it a little quicker. We're going to have attack power, and we're going to say just equals attack power. I mean, we could change the names up if we wanted to, but we're going to basically just kind of keep it the same as the parameter name to make it a little simpler. And well, let's make it a little different. I mean, that's long for people to have to deal with, so we're going to change that to something a little easier: attack and defense. And defense would just be the defense power. So these in our card game are little fantastical monsters would have a name, an attack power, and a defense power. Okay, so these are the attributes of the object, which in this constructor lets us, when we create a new card, we're able to give a name to it, attack power, and a defense power. But let's add some more to it. Let's make a method. Let's make a couple methods. And if we were to make some more complex, we might even get into 20, 30 methods. So you get really complex with these objects. We're going to call it attack roll. It's here associated with self. And the method is going to return. We have it return the whatever the self attack is. But to make it a little more neater, more than cards, almost like a dice that you roll with the cards, or like if you were to play one of these RPG games where you run into other little creatures, or you try to catch the Pokemon or whatever. There's a lot of times there's an element of randomness, which is always kind of neat. So we're gonna say attack is basically the attack power that they were given, but we're gonna random. We're gonna throw the dice here, and we're gonna say random, and we're gonna do random int. And there's other things we can get from the random module, but for this we just need a random int from 1 to 3. And that looks pretty cool. So we have attack roll, but let's also make a defensive roll, because later in the game we might want to see, well, if the attack roll is more than the defensive roll, this card wins over that card type thing. And we're not gonna get into the full make a full game. That's gonna take a while. I mean, even if it was a non-graphic game, all the rules, attack versus defense, it could take a while. If we were to make it graphical, we'd have to import graphic modules to deal with it, drawing the graphics. But you could get pretty detailed and do some pretty impressive things. Just this little piece of code that we're gonna do today, you'd be able to, looking at it, you should be able to, or when it's done, be able to see that if we really add on to it, we could use this object to make something pretty complex and pretty impressive. This would be a start of a kind of neat object. And let me go down here, hit the wrong button, and return. And we're going to do the same thing that we did for the defense with the defensive role. So we get the attribute, whatever attribute we assign it, and then we're going to do the random 1, 2, 3. Okay. That's looking good. I think we have our first run at the object, maybe our only run in this demonstration of the object. So now let's make a couple cards. We're going to call the first one card 1, and we're going to go and define it. Right here, we're using the class, we have card. So what we're saying here is, hey, we want a card, and this time it's a little more complex than this one up at the top. That's and we can take in basically 3 parameters: name, attack power, and defense power. So for the name, this little creature will be called the Mega Frog. And Mega Frog has what comes next, attack power. Let's give it 7 attack power. And let's say Mega Frog has a defensive power of 5. Okay, pretty cool. We have a Mega Frog. And let's make a card 2. Card 2. Here we go, card. And this one's going to be called Ultra Mouse. And the Ultra Mouse will have attack power 4. We give it a little less attack power, but a 5, or no, have a 6 in defensive power. Ultra Mouse is really quick, and that adds to his defensive abilities. Or you could write whatever backstory you want if you're the person creating the game. And let's do some quick prints before we get into anything interesting. Before we actually start using the methods, we're just going to print some attributes out here really quick of our 2 cards. Card 2, attack. And let's also print some defense. Card 1, defense. Okay. Card 2 over there. Okay. So let's run this really quick. Make sure we have everything right before we get too far. Okay. So we import random, we make our class. Right here, what we're doing is we're making a object from that class, and we're card 1. We're using the card object called Mega Frog, and card 2. So we have 2 cards defined, and you can see how we printed the attributes of attack and defense power from them. Okay. So now we really have the basic of some a little more complex. So let's do a print. Card 1, name, and we're gonna say attacks. With, and then we're going to say what they attack with. Card 1 dot attack roll. And this is where what I think is really neat here is because right here we're making it roll basically a die for us within this object. So it's going to grab it's going to go up here when we hit that method, and this object that we define, card 1 over here, will have this code, basically associated with it. So whenever we hit that method, it's going to come here and figure out the attack power that we gave it, itself's attack power, and then times that by a random number between 1 to 3. So it'd be a 1, 2, or 3, which is pretty cool. And as you could probably see, pretty useful if you're making a game. So it's a foundation of a game. And if you look behind maybe some of the more complex games that you might have seen out there, you have something like this, maybe defining the cards or the creatures in the game, and that's how it's done. Of course, it'd be maybe a little more complex. You might have images associated with it. You might have all sorts of things, but this can be added upon, and this is the real beauty of object-oriented code. So card 2 defends with, and now we're not going to use attack roll. We want to use the defense roll. So if you can envision, these are just 2 cards, but imagine 400 for a couple players or multiple players, or a giant world with instead of cards, creature 1. So it's very useful to define similar things in coding with object-oriented code, because every time we make a new card and pull in card object defined here in the class, we have everything we put in here. And this is not a lot of lines of code, but imagine you have a lot of lines of code doing all kinds of neat things. You could do some pretty impressive things with that, and that's really one of the big benefits of object-oriented programming. You define it up here, and then every time you make one of these objects from this class, you have all these attributes and methods at your fingertips. So let's run this a couple times. Okay. First time we have the battle between the Mega Frog and the Mega Mouse, and that frog attacks. Mouse defends well and gets away. So then we could do it. We could run it again. And we can run it again. Got the same result. Oh, this time we got some different rolls. So this time it took a couple attacks, but eventually the frog beats the mouse, and the mouse faints, or whatever the Pokemon do, or whatever it's done in the game. Your battling monster returns to the cage, or whatever you want to do in your game. You have it there. Of course, some more complex. You could take turns. You could flip back and forth. Like one player attacks, and the next player gets his turn to attack. So, however you define it, you can do it. But the foundation of it is object-oriented programming, where you define a class of relevant objects or things that you want to behave in a similar manner. And really, really useful in complex programming. In something small like a moving data here to there, I'm running some scripts. I love to use Python for a lot of things. There's no way I'm going to waste time building classes. But if I'm doing like a game with useful things, or if I'm doing a like an inventory system, and I want to have a store item, the items of your stores can be, you have an object store item, and store item would have a price. It would have all these things associated with it, and that's these types of things is what you want to use object-oriented programming for. Things where you can envision like an item, a card, anything that might have a fairly complex set of rules that you could define within a class, and then you have multiples of them. So object-oriented programming, very useful. Now what I'm going to do is I'm going to change attribute here. I'm going to say attack for the card 1 equals 10. And let's just print this. Print card 1 attack. Okay, so you see how it let me change the card 1 attack, and we printed it. Let's say you want to have attribute that you don't let people at in your program. Let's say we have full control over it because we're making everything. But let's say you're making a module that someone imports, kind of like we imported the random. And so you'd import your objects, but you have something that maybe when you hand it over to someone else to use, maybe you're selling a product, your module that you created, you're selling for a business, and it does their inventory or whatever, and you wanted to use some in there, or maybe it's the base stock or base code for a game that you have your own module, and that would kind of relate to this card game we're working on, but you want an attribute that you can't just change. A way to do that, a hidden attribute, is this. So we're going to add another attribute here, this one that people can't touch. And we put a double underscore in front of it, and we're going to call this the hidden number, and we're going to say it's equal to 3. Let's just run this really quick to make sure we didn't introduce any errors, and we didn't. Now we know we have a hidden number in here, and we're going to use it in our program. So let's subtract it from here, and so we're going to use this hidden number in our formula. It's like a secret number that we have here. And let's run our program again. So now that number is going to change stuff. Okay. Have some off here. Did I go do that right? Self hidden number equals 3. Oh, there we go. It's self dot hidden number. So let's update this. Okay, because we have to refer to the object itself. So let's run this again, and now that number's doing things. It's knocking things down and changing some of the normal outcomes. that we would get. And we have like a 2, and before I don't think it was even possible with the with that defense score for the Ultra Mouse to get a 2, but now we can get a 2. So let's work on doing some changes here to this. So you have this hidden number, and let's say you want to see this hidden number. So we're going to go card 1, and we want to, where's the hidden number verbiage? Okay, so you'd think you'd be able to do this, or maybe you think you won't be able to do this, and it's true that you can't, because even though it's an attribute and we're using it in our code, it's doing subtraction and causing all kinds of ruckus in this attack and defense, but we can't see it in a normal normal manner because it's a hidden attribute. Now there's a way we can give people access to it if you wanted to. So I'm gonna kind of cover that up, and we're gonna make a quick code change here, and we're gonna add something new in here. And at the end of this, we're going to add a property. Do it like this: property, the @ symbol, and property, and then you can go, and we would call it hidden number. We won't have the remember the double underscore up here. Make sure it's truly hidden, but we're going to call this hidden number. Just so we know we're going to be talking about the same number. And on self, oops, let me get that right. And so this property, we're going to have it return self that double underscore hidden number. So what we're attempting to do is make this number not hidden, but it's still going to be protected, because we're not going to give it, at least thus far. We will a little later. We'd give people ability to change it, but for right now, we want to keep it. We want to keep it not hidden, but untouchable. So this number is going to be no longer hidden, but it's still not going to be touchable. So now to access this, do a print card 1, and what do we call this? Just plain hidden number. So now this is going to let us see the number. Okay, now we can see it's a 3 in there, causing us these differences in numbers. So we know the hidden number it's no longer hidden. It still is a hidden number. We have it hidden. But it's still untouchable, in that we can go card dot hidden number. So let's say the people that let's say you're not using this yourself. Someone else uses your module, and it's your module, and and you're keeping it. You're keeping your secrets, I guess. And they're going to try to set it, and they're going to go, well, that 3 is just too much. We're going to set it down to 1. And that's what they want to do. And then it goes, you cannot set an attribute because we changed it, and we don't give them the ability to set it. It's what this is. It just returns this. No way. There's no way to set it. And so we don't give them a chance because they can't go in, by double underscore because it's just hidden. And we gave them this nice little app property. They now can view it, so they know what's getting used. They know what's there, and this would be a good way to keep some that you wanna keep track of. You don't want people messing with it, or the program itself, maybe yourself accidentally messing with it. That's a good way to lock this down. Because maybe you don't want any crazy values like 100 in there, or something like that. But let's say you decide, well, I'm going to give them. You want to give them You want to give them the power to get in there, to set that. There's a way to do it. And you could also add some code in there to limit it. I'm not sure if we're getting there, but at least show you how to set it. And then if you want to go further than there, you can use like a if else if to see if numbers less than whatever. You could raise an error. You could do lots of things. So we'd have a way to let people at these numbers, but in a controlled manner. So let's make another change here. We're going to once again use the @ symbol, but this time we're going to get the name of what we're going to call this. We're going to call it hidden number. So we put the name of what we're going to call it, and then we're going to put setter. And that's really the key word here, setter. So and then that's saying that it's used to set. And then we're going to define it. So we're def statement and hidden number again, self, and because we're referring to it, and then hidden number. We're going to call it. Don't have to call it that, but that's what we're going to pay. We're going to pass it the hidden number, so it's going to take a parameter. And if we have this parameter, let's go self. Let's do something with it, and since it's setter, we can set this, and we're going to set it hidden number equals the parameter pushed in here, up over here, hidden number. And like I said, we can add some changes around this. We can if, like we say, if this parameter coming in hidden number is greater than 10, it equals 10, so they could type in 100, then 200, whatever. We're going to reset it on them. I mean, there's lots of things we can do from that. Let's just first run and check it out for syntax. Okay, the syntax looks good. Let's go over here and let's try this to set this. So we go hidden number And yeah, this time it should work. In fact, we ran it and it did work this time. So let's run it again. Oh, well, let's print it. So what we did, we tried to set it. So let's go here, put this here. So when the program starts, any of these objects that we define, card 2, card 1, they're going to have this hidden value that we're having to do some subtraction in the attack and defense calculations. And we made some changes to make this hidden number setter, and we call this just hidden number. And so it allows us to actually set. And so let's set it and see what we get when we print it again. So we're gonna, you see how it's at first it's 3 and now we set it to 1. And let's say they put in 100. Let's run this and it's 100. But you want to set something else in there maybe. So you go if hidden number greater than 10, and then if it is greater than 10, we're going to go hidden number make a block here. We didn't make a nice if block, did we? So if it's greater than 10, we're just going to leave it at 10. So we just fill it with 10. And let's put an else in there. Be at this level. Else, oops. We need to change that to lowercase. And on the else, gotta start the cold block here. And else hidden number equals hidden number. So what we have now here is this, we have code that limits it. So we didn't have to hide it if we wanted to just allow people to write anything. It'd be easier to keep it non-hidden and show it. So, but we kept it hidden, and then we decided to let people see it, and then we went the next step over and say, hey, we're going to do more than let you see it. We're going to let you change it. But just not doing anything would be the same as just never leaving this hidden in the first place. So we're going to let people see it, but we're going to set rules down here. And that's the real thing behind just letting people freely go in here. This sets rules. It enforces rules. You could raise eras. You could change numbers, which we're doing here. You could do lots of things. So let's run this. And if you look here, you can see what now happens. We try to set to 10, but or try to set to 100, but it says no, that's greater than 10. We're gonna force it to 10. So we're not going to show in this example, but what you probably want to do, maybe you don't want it to go anything less than 1. So if it's less than 1, you can set it to 1. So you could add a little more complex logic in here because negative numbers do crazy things. You don't want that to happen. And that's the real whole idea of this, is that, okay, we're going to allow our object to be changed, but we want to put some rules on it. This is really a locking down with code, so you could put your own rules in there, as opposed to anything goes. In most cases, in simpler programs, you're not going to need to lock anything down. But there are a lot of cases that you will want to lock things down, especially if you're selling some sort of commercial module for special business need, and you want to you better the product by, if you're actually selling this, to not let people put bad data. So you could put a lot of data quality checks in there, and you could do it right in here with the and then whatever your name of it is, setter. So that's a way to lock down, to put some data quality in there, to do some more important cleansing that you might have to have a really polished, professional level product.